Hello, good day everyone. You are welcome back to another interesting maths question. We are to calculate the area of this square-shaped quadrilateral with the length A. Let's label the points. Say this is P, this Q, this R, this S, this T. Say here A, this B, and this C. So we are to calculate the area of this square CPQT. From here, we are told that there are two squares here. That is, just as this is a square, this is also a square-shaped quadrilateral. We have the area of this triangle ABQ to be 40 meters squared, and that of this triangle BCS to be 24 meters squared. So how can we solve this? How can we calculate the area of the square CPQT? Well, we know the area of a square is equal to the square of the length of one of its sides. And here, the length of this side of the square in question is A. Therefore, area of the angle CPQT equal to A squared. Now as the value of A, we don't know, but still on the square, one of the properties of a square-shaped quadrilateral is that all four of its sides are equal in length. That is, this side, this, and this are equal in length. So since the length of this side is A, this, and this must also be A in length each. But this side is divided into two segments, this and this. So since the sum of their length is A, if you assume the length of this segment to be x, this must be A minus x. The same is for this side here. It is also divided into two segments, that is this and this. So if we let this be y, this must be A minus y. Now another property of the square we haven't mentioned is that all four of its angles are right angles. So this angle, this, and this are right angles. The same properties we mentioned for this square are also applicable to this square here. All its sides are equal in length. So if you assume the length of this side to be C, this side, this, and this each must also be C. But this is divided into two segments. If we let this be n, this must be C minus n. All the angles of the square are right angles. Therefore, this angle, this, and this are right angles. Now let's come to this triangle APQ. Attempt calculating its area. It is a right angle triangle. The formula for calculating the area of a triangle is 1/2 base times height. When it comes to a right angle triangle, the legs are the base and the height. So if we take this as the base, this must be the height. So base equal to A minus x and height equal to A. Substitute it here. Now area of triangle APQ equal to 1/2 times A minus x times A. A minus x times A is A times A minus x times A. A times A is A squared. Minus x times A is minus AX. So it is A squared minus AX. Therefore, area of triangle APQ equal to 1/2 into bracket A squared minus AX. That is, the area of this triangle is 1/2 A squared minus AX. Come to this triangle also, it is as much a right angle triangle. So if we are to calculate its area, we use the formula 1/2 base times height. Here, definitely, if we take this as the base, this must be the height. So base equal to x and height equal to a minus y. Substitute here. Now area of triangle ABT equal to 1 over 2 times x times a minus y. X times a minus y is x times a plus x times minus y. X times a is ax and x times minus y is minus xy. So it is ax minus xy. Now area of triangle ABT equal to 1 over 2 into bracket ax minus xy. So the area of this triangle is 1 over 2 into bracket ax minus xy. Now come to this triangle BCQ. It is also a right angle triangle. To calculate its area, we know if we take this as the base, this must be the height. So base equal to y and height equal to a. Substitute it here. Now area of triangle BCQ equal to 1 over 2y times a. 1 over 2y times a is 1 over 2ay. So the area of this triangle is 1 over 2ay. Now if you noticed, it is this square CPQT which is divided into these four triangles. This triangle APQ, this triangle ABT, this BCQ, and this ABQ. And we have the areas of each of the triangles. Definitely, the summation of their areas will be equal to the area of the square. The summation of their areas is the sum of this, this, and this, and the area of the square is here. So therefore 1 over 2 into bracket a squared minus ax plus 1 over 2 into bracket ax minus xy plus 1 over 2ay plus 40 equal to a squared. This 40 is half 80. From 1 over 2 into bracket a squared minus ax plus 1 over 2 into bracket ax minus xy plus 1 over 2ay plus 1 over 2 times 80, we can see 1 over 2 is common. If we factor it out, it is 1 over 2 into bracket a squared minus ax plus ax minus xy plus ay plus 80. Here minus ax plus ax is 0. So it is 1 over 2 into bracket a squared minus xy plus ay plus 80, which equal to a squared. Multiply both sides by 2. Here, this 1 over 2 multiplied by this 2 is 1, while here a squared minus 2 is 2a squared. So a squared minus xy plus ay plus 80 equal to 2a squared. Subtract 2a squared from both sides. Here 2a squared minus 2a squared is 0, while here this a squared minus this 2a squared is minus a squared. We take a transpose of this 80 to the left. So minus a squared minus xy plus ay equal to minus 80. Multiply both sides by minus 1. Here minus a squared minus xy plus ay all multiplied by minus 1 is plus a squared plus xy minus ay. While here minus 80 times minus 1 is plus 80. So a squared plus xy minus ay equal to 80. Now we keep this equation aside. Come back to this triangle. Assume the size of this angle to be r. Now use the SOHCAHTOA tool on the triangle. Taking this angle as theta, this is the opposite and there is the hypotenuse. From here, sin theta equal to opposite of our hypotenuse. Theta is r, opposite is a, and hypotenuse is c. So sin r equal to a over c. We come to this triangle now. Its area is 24 meters squared. The formula for calculating the area of a triangle is 1 over 2 base times height. If we take this side BC as a base, the height will be a perpendicular line from the base to the opposite vertex. Let's say Z. So base equal to y and height equal to Z. Substitute it here. Now 24 equal to 1 over 2 yz. Multiply both sides by 2. Here 1 over 2 yz times 2 is yz, while here 24 times 2 is 48. So 48 equal to yz. That is yz equal to 48. Now we come here, extend this line to meet another line from this vertex parallel to this side. Since it is parallel with this side and this is perpendicular with this side, the new line will also be perpendicular to it. Similarly, since this is a right angle, this must also be a right angle. Now look at this quadrilateral. The fact the four of its angles are right angles tells that it is a rectangle. Opposite sides of a rectangle are equal in length. That is, this side and this side are equal. So since this is z, this must also be z. Now come here, look at this angle r, this right angle and this angle. They align on the same straight line. We know the angle on a straight line is 180 degrees. So since this is 90 degrees, this must be 180 degrees minus 90 degrees minus r. 180 degrees minus 90 degrees is 90 degrees. So it is 90 degrees minus r. Now from this triangle, we know since it is a right angle triangle, and we have the size of this angle to be 90 degrees minus r, this must be r. So if you now use the SOHCAHTOA on the triangle, taking this angle as theta, this is the opposite, and there is a hypotenuse. We know sin theta equal to opposite over hypotenuse. Theta is r, opposite is x plus z, and hypotenuse is n plus c minus n, which is c. So sin r equal to x plus z over c. Recall here, sin r equal to a over c. Substitute it here. Now a over c equal to x plus z over c. This c will cancel this c. So a equal to x plus z. Subtract x from both sides. Here x minus x is 0. So a minus x equal to z. That is v equal to a minus x. Come here, yz equal to 48. Replace this z with a minus x. Y times a minus x is ay minus xy. So ay minus xy equal to 48. Multiply both sides by minus 1. Here minus 1 times ay minus xy is minus ay plus xy, which is xy minus ay, while here minus 1 times 48 is minus 48. So xy minus ay equal to minus 48. Come to this our equation. A squared plus xy minus ay equal to 80. Replace this xy minus ay with this value. So a squared minus 48 equal to 80. Add 48 to both sides. Here minus 48 plus 48 is 0, while here 80 plus 48 is 128. So a squared equal to 128. Come here, replace this a squared with 128. So area of square CPQT, which you are asked to calculate, is 128 meters squared. Thank you for watching. Please subscribe, like, share and comment, and also turn on notifications. Thank you.